So this last section is just a catch-all for all the things that we needed to chat about that sort of finish up the linear regression section. So one is this idea of extrapolation. And extrapolation is just making predictions outside of the range. So that's extrapolation, is predicting outside of the range for which you have data. So I've got a silly comic here to sort of nail that in. I also will want to go back to that systolic blood pressure versus weight. So essentially, we can only make predictions for the data that we have observations for. So we can make predictions from about 166 to about 220. Anything outside of that range, we're not so sure what's going to happen. Now, obviously, it wouldn't be terrible to do something just outside, like a 160. But if we're going to try to predict what happens for a 300-pound person, we don't know what happens with this linear, with this trend after. It is possible the trend continues exactly as it is. But more likely, especially for something like systolic blood pressure, this eventually evens out, right? Or maybe it gains exponentially. We have no idea. So we should not be making any predictions outside of the range of our original data. And if we are, that's extrapolation. So this question on an exam, it's usually obvious because I've given you either a scatter plot or some information saying what my y values were. So if I give you the range of the original y's, then you want to be very careful that any predictions we make are within that range. If they're not, then we can't be very comfortable with them. So y hat, sorry, not range of the original y's, range of the original x's should only be from x inside that range, okay? The second thing we want to be careful with linear regression is combining different groups. So I have this example here. We have world record times for the 10,000 meter run. And you can see what's happened here. We have what looks like two distinct trends happening. And if we fit one line to it, we're going to do really poorly for both those trends, right? For all of these people in this trend, we are going to over predict what their times would be. For everybody in this trend, we're going to under-predict. And I want you to take a second and just think about what these two different trends might be. And hopefully you realize we have males and females, and these are the different world record times. So females tend to be slower than males. The males, we've obviously been collecting their time since 1910, where it doesn't look like anybody had female data until about 1960, a little bit after that. But yeah, that's sort of why you don't want to combine different groups. And that's something we're actually going to see in the computer assignment for this week's coming module. So types of unusual points is the last piece. We've been talking a lot about unusual observations when it came to scatter plots and residual plots. But there's three different ways a point can be unusual. So we have three definitions here. One is a point can have high leverage. So this is very much like that one person in that UC Davis example. I'll scroll back to it. In this UC Davis, this point had high leverage. What this means is it's far away from our average X. So the majority of people spent around 20 hours on their computer. This person spending more than 80, this had a lot of influence on what was happening with the actual regression line. That's why it ended up so close. So, sorry, so much scrolling. So that's high leverage. So that means far to the left or right, away from all the data. Outliers are any point that stands away. This could be because it has high leverage, like that guy in the computer, or it could be like those other two people who had GPAs that were grossly over-predicted. So influential points, the last thing, this is a point that actually really influences the linear regression model that was attained. So I sort of want to draw a couple examples, but let's just do this exercise first. I think this X is supposed to be over here. I want you to decide what's going on, whether this falls into any of these different categories. So leverage, yes or no? Should be a yes. It is far to the right, right? It's just like that guy with the amount of time he spent on the computer. 70 is nowhere near our average of about 20. So this definitely has leverage. It is an outlier because it is far away from the rest of my data. And now we get to that influential point. And this is where you kind of want to think about this like we did that earthquake data back in the correlation section. If we ignore that point, what does the trend of our data look like? And then if we include that, if we include that point, what do we think is going to happen with the line? So in this case, the line is going to try to split the difference when it's coming up with those squared residuals. Squaring this giant value is going to be a big issue. So we probably want something that's going to look like this, where this is going to kind of even everything out. So this would also be an influential point because the line I drew is different with and without that value. So this is everything special. So if you wanted some examples of things that fall into like different categories here, let's just do a couple more drawings. So one possibility is, what if we have that point, that X, but it's on trend, right? This is on the trend of the data. So this would still have high leverage because it's still far to the right. It's still an outlier because it's far away from the rest of the data, even if it's on trend, but it is not an influential point because my line that I would draw through this data is the same with and without that value. It doesn't change the regression line whether it's in there or not. So that is one example. Another example would be if we have our trend. I'm just kind of keeping the trend similar, so this positive trend, but now our X is kind of here. This has very low leverage to no net leverage because it's sitting right smack dab in the middle of the seesaw, right? It's right in the middle of my X values, so leverage is not an issue. It is an outlier because it's far away from the trend of my data. And then when it comes to influential points, this is a little bit funky because our original line would go through the data, right? Our new line with that X is not going to get pulled too far up. In fact, it's probably aggressive even that because the difference here, it's going to make every other point off as it pulls up. Whereas on the original one, it only really influenced these last couple points when we pulled it up because it was so far off to the side. So when you have low leverage, it's hard to have a lot of influence on the line. And if you think about the influential point here, will influence the y-intercept only. The slope is not going to change because it's smack dab in the middle of the seesaw. So it's sort of a questionable in terms of whether it's an influential point or not, sort of. I've never put this question on the test and then asked about influential point, but I have asked about leverage and outliers because I think that is very clean cut in terms of what's happening. So anyways, that's sort of all the different situations that you might see and how we can use those definitions within them.